Today's topic is Zener Diode. So Zener Diode is a more heavily doped PN diode. It's designed with adequate power dissipation capacities to operate in the breakdown region. So it has it's also voltage reference voltage regulator, or it's called breakdown diode. So the symbol of Zener diode is it has a small tilt in the up and bottom, similar, but it's similar to PN diode. The forward bias characteristics of Zener diode is very similar to PN junction diode. So this is for this first quadrant is for VF and IF forward bias, so which means the anode is connected to the positive of the power supply and cathode is connected to negative. So after the cut-in voltage 0.6 or 0.7 voltage, the diode starts to conduct, and as the voltage increases, current also increases. This is similar to forward bias PN junction diode characteristics. In reverse bias, what happens is breakdown happens. So it slowly increases, and then the voltage is current is constant, the voltage increases, and after some time voltage is constant and current increases rapidly. So this region is the breakdown region, where the Zener diode can be used as voltage regulator. So the two applications of Zener diode are, it can work either as voltage regulator, where the voltage is constant and the current is increasing rapidly, or it can be used as a fixed power supply voltage. So the breakdown voltage increases for a lightly doped diode. So we have two types of breakdown here, Zener breakdown and avalanche breakdown. If the breakdown voltage is less than 6 volt and it is a very heavily doped diode, it operates in Zener breakdown. The breakdown voltage is greater than 6 volt and it is a little lightly doped diode, avalanche breakdown happens. So in the reverse characteristics of Zener diode, so this is the knee voltage and this is the breakdown region or regulation region. In this region, regulation does not happen till the knee voltage 0 to K, till the knee voltage regulation is not happening here. The features here, and after MM is the rated voltage, maximum voltage, which is given in the specification sheet, after which if we increase the voltage, diode gets damaged. In this is the IZX, the minimum current, and IZM, the maximum Zener diode current. So there is a minimum value of Zener current called breakover current IZK or IZmin to keep the current in diode in breakdown or regulation region. When current is reduced below this knee voltage, it does not work as a regulator. Maximum voltage is IZM or IZmax, above which the diode gets damaged. The maximum power dissipation of Zener diode. So Zener diode specifications, it can be given by maximum power dissipation, Zener voltage, maximum power dissipation, PZM or PED max or PZ max. So Zener resistance, the breakdown voltage is from 1.8 volt to 2000 volt. The power dissipation PZ is equal to VZ into IZ, Zener voltage into Zener current. The power rating is from 150 milliwatt to 50 watt. IZM is equal to the power divided by the voltage power rating of Zener diode PZM divided by VZ, the breakdown voltage. Zener diode with maximum power dissipation below 1 watt have glass packaging, while those with 1 watt use metal case. So power dissipation less than 5 volt use somatic packaging. So they can be there with or without leads. Zener diode equivalent circuit. So the ideal Zener diode is equivalent to a voltage source having voltage VZ. Practically there is also a resistance in series which is RZ. So practically a Zener diode is equivalent to a voltage source with fixed voltage VZ in series to a resistance RZ. This totally is called VZ dash. So practically there would be a small slope in the curve. Ideally, as voltage increases, current increases rapidly and it is a straight line, which means it does not have resistance. Practically, as voltage increases, current increases slowly. So we have some change in voltage del Vz and change in current del Iz. So there is some resistance Rz which is equal to del Vz by del Iz. So for perfectly vertical breakdown curve, value of Zener is practical, vary from few ohms to hundreds of ohms. So it's equivalent to a Vz in series with Rz. So Vz dash is equal to Iz Rz plus Vz. The applications of Zener diode, it acts as voltage regulator. It acts as a fixed reference voltage in transistor for biasing circuits. It can be used for peak clippers or limiters in wave shaping circuits for meter protection against damage from accidental applications. So this is about Zener diode. Thank you.